We're going to find the intercepts and test for symmetry the equation x squared plus y minus 9 equals 0. Let's start with the intercepts. We're going to find the x-intercept. Remember, to do that, you need to let y equal 0 in the equation. We get x squared plus y is 0 minus 9 equals 0. Or x squared minus 9 equals 0. We could, if we wanted to, solve this equation by adding 9 to both sides of the equation and then square rooting both sides of the equation, or we could recognize that x squared minus 9 is the difference of two squares, which factors to x plus 3 times x minus 3, and that equals 0. Use the zero product property, set each factor equal to 0, x plus 3 equals 0, or x minus 3 equals 0. So x equals negative 3, or x equals 3. So your x-intercepts are negative 3 and 3. To find your y-intercept, you let x equal 0. Letting x equal 0 in the equation, we obtain 0 squared plus y minus 9 equals 0, or y equals 9. So your y-intercept is 9. In general, your intercepts are negative 3 comma 0, 3 comma 0, and 0 comma 9. Next, we want to test the equation for symmetry. Remember, there are three types of symmetry that we're going to test for. X-axis symmetry, which means that if the point xy is on the graph, so is x negative y. So in the equation, the test for x-axis symmetry, we replace y with negative y and see if the same equation results. By same, I mean if we get the original equation back. Well, upon simplifying this expression, we get x squared minus y minus 9 equals 0, which is not equivalent to the original equation. Therefore, this graph will not have x-axis symmetry. Next, let's test for y-axis symmetry. If a graph of an equation has y-axis symmetry, if the point xy is on the graph, so is negative x comma y. So we replace x with negative x in the equation and see if an equivalent equation results. Well, negative x quantity squared is x squared plus y minus 9 equals 0, and we can see that this equation is the same as the original equation, so the graph of this equation will have y-axis symmetry. Finally, we can check for origin symmetry, which means if xy is on the graph, so is negative x comma negative y. So to check for origin symmetry, you replace x with negative x and you replace y with negative y. If an equivalent equation results to the original, then we have origin symmetry. Well, negative x quantity squared is x squared, then minus y minus 9 equals 0. This equation is not the same as our original equation, so the graph of our original equation will not have origin symmetry.